Alright, so I'm back again and I want to talk a little bit about integrals and anti-differentiation. And I want to start off with the basic rule. I want to show what it is and how it works. So here we go. We have our integral x to the n dx. Now this is for all polynomials of this form. So for example, f of x equals x squared. So n in this case is 2. F of x equals 3x to the 4th. So even though we have a 3 here, n is still 4. But what happens if I have f of x equals radical x? Well, now this is not in that form right there. So I have to transform it and make it into f of x equals x to the 1/2. Now n is 1/2. Suppose I have a function 1 over x cubed. So this can be integrated in this form. We have to change it to x to the n. So we have f of x equals, all we do is find the reciprocal, x to the minus 3. For this one, we just change it from a radical to the 1/2 power, or what we would call an index. So here's the rule. We add 1, and we divide by the new exponent and write a plus c for our arbitrary constant. So let's try a couple of them. F of x, we're going to start with x squared dx. So now I want to add 1. So I have 2. So I'm going to write my base x, and I'm going to put my 2 here, and I'm going to add 1, and I'm going to divide by the new value of our exponent, which in this case is going to be 3, and the rule tells me to write plus c equals x cubed over 3 plus c. That's all it is. Let's try another one. So, erase this here. Let's try integral square root of x dx. Now we've already learned a few seconds ago that we cannot integrate this function in this form. We have to change it to a form that has a base to a power. So I'm going to write my new integral, x to the 1/2 power dx, same thing. In fact, we don't need this equal sign here. And now I'm going to add 1. But this time, because it's a fraction and it's an index, I'm going to add 2 divided by 2. Now, if I add 1/2 plus 2/2, I end up with 3/2 plus c. Now we have a little bit more work to do on this one. So I'm going to write x to the 3/2. I'm going to multiply this by its reciprocal and get 2/3. And I'm going to go ahead and write my plus c. So let's try another one similar to this, where we have an exponent that's an index. Now, let's see. Integral, let's try the cube root of x dx. Now, once again, we have a function that's not in the power form. we have to change it to its power form, just to the 1/3 power dx. And now I'm going to integrate this. So 1/3 plus, what's the denominator here? It is 3, so I'll write 3 over 3 divided by the new, which is going to be 4/3 plus c equals, I'll put my rest of the problem here. I'm going to multiply by the reciprocal and have 3/4 x to the 4/3 plus c. Alright, now there was another one on our list over here. This problem right here. So I'm going to go through this and I'm going to show you how this is the same thing as accomplished. Because we know if I have a polynomial or an expression like this, and we're just going to say that the polynomial is in the denominator. So it's 1 divided by it. This is not in the power form. So you have to transform this to the power form, x to the minus 3. So what have I done? All I've done is change this to its reciprocal. And now it's in the power form, x to the n is minus 3. I'm going to add 1, minus 3 plus 1, divided by the new exponent, which is minus 3 plus 1 is minus 2 plus c. Now we have a lot of simplifying to do here, and I'm going to show you how to simplify this. So the first thing, I'm going to make this x to the minus 2, and I'm going to move this, I'm going to keep this down here, minus 2 plus c. And now I'm going to finalize it by finding the reciprocal of this, because we don't want any of our exponents to have negative powers. So I'll end up with negative 1 divided by 2x squared plus c. This negative came from the negative in front of the 2, and this negative, the reciprocal of it, now becomes positive. So now I'm going to put some problems up here for you to try, and let's see how you do them. So we finished with these. So let's say that I have f of x equals x to the 4th, f of x equals 1 over root x, and f of x equals 1 over x squared. So stop the video, try them, and then I'm going to go over them, and let's see what we come up with. And let's see if our answers agree if you use those powers.